In our final lecture on application layer protocols, we're going to talk a little bit about network time protocol. So network time protocol is used primarily to sync up clocks of different computers on a computer network. So why do we need to synchronize time? Well, there's a lot of different reasons, and the desire to synchronize time is increasing daily. One of the reasons that's for the increased need to synchronize time is the use of authentication, such as digital signatures, other authentication keys. Very often have timing parameters for them to be considered valid, so it's very important to have accurate time between different users. Also, in any network where you have to have keep log files to troubleshoot when a situation has occurred, whether it's a security breach or maybe some customer has some difficulties. It's up to very important, especially for network switches, to have accurate and consistent time. Also, many times you have a system that may have real-time or soft real-time requirements. Say, for example, a factory automation system will have real-time requirements. Obviously, that everything is timed out in a certain way. The assembly line moves at a certain very specific pace, and the robotic arms move at a very specific pace, and that relies on everything, all the computer systems in a automated factory to have accurate time. Also, soft real-time systems, such as any type of fly-by-wire system on an aircraft, where there's soft real-time requirements where you're using computers to control a manual device, where you're also moving and calculating speed and other parameters. You need to have all the different systems have accurate time, and have accurate time based on a single time source. So to do this, we use what's called network time protocol. It's one of the oldest internet protocols, and it uses UDP, and it's on port 123. The current version is NTP version 4. We're going to talk a little bit about version 3 and version 4 in this lecture. Version 3 is a default for Cisco devices, and NTP provides time referencing the Coordinated Universal Time, or UTC time. NTP uses basically a hierarchical system called a clock strata. So different devices that are using NTP are in different parts of the strata. So basically, it's a hierarchical, semi-layered system of levels of clock sources. It's kind of very similar to almost like a root directory structure. Each hierarchy is termed a stratum, and layers are assigned starting with 0, basically the root, at the top. So clock strata, in clock strata you have stratum levels define the distance from the reference clock and exist to prevent cyclical dependencies in the hierarchy. In other words, you don't have a situation where one clock is dependent on another, which is dependent on another, and you go in a circular fashion. So basically, you start off at the top with a very reliable time source, and then you work down. So basically, NTP uses the concept of a stratum to describe how many NTP hops away a machine is from an authoritative time source. And that's basically, the further you are away, the longer it's going to take you to eventually get the correct time. NTP supports up to 256 strata in version 4. And other versions support a little bit less, but 256 is a bit large. If a Cisco device is set up to be an NTP server with the MTP master command, then it will default to a stratum of 8. So most Cisco networks start off with a stratum of 8, which is a little bit more manageable. So we start off with stratum 0. At stratum 0, you're going to have some sort of device like a cesium beam clock or an atomic clock, or maybe a GPS clock or some sort of radio clock. But this is where you're going to have your most authoritative time source, so something that is extremely accurate. You may even have a backup system, and the two time sources sync up with each other. But that's what you usually start off at stratum 0. Then below stratum 0, you have stratum 1. So at stratum 1, these are going to be your time servers for your network. They're basically, these computers at stratum 1 are going to directly attach to your stratum 0 device. And they will basically act as time servers for time requests from the stratum 2 servers via NTP. These computers are also referred to as your network time servers, because they'll be serving time to stratum 2 devices, and those stratum 2 devices will serve time to stratum 3, and so on and so on. Stratum 2 computers normally act as servers for stratum 3 requests, and of course this goes on and on. We're going to talk a little bit about NTP version 3 and NTP version 4. For the purpose of this lecture, we're not going to talk about all of the modes, but keep in mind that NTP version 3 has 5 different operational modes. It has a symmetric active, symmetric passive, a client, a server, and broadcast. The client mode is a mode that is used most often. This mode uses the standard client-server model. So when a networking device is operating in client mode, it polls as assigned time server for the current time serving hosts. It polls the assigned time serving hosts for the current time. Okay, I think I have a little duplication here. It polls the assigned time serving hosts for the current time. The device will then pick a host from all polled time servers to synchronize with. So usually in NTP, usually a client has multiple time servers that it can choose from. And basically it chooses one and it synchronizes with that one that it has chosen. Symmetric active mode is used when there are multiple mutually redundant servers are connected. Now, very often in a critical system, you're going to want to have multiple time servers at each stratum, just in case if something happens to one and it crashes, it's going to be detrimental if you have to keep accurate time. So very often you have mutually redundant servers at each stratum level. So what happens in this case is the end station needs to specify which device to peer with and set the device to symmetric active mode. The NTP protocol usually starts with sending packets every minute, then settles in by sending and receiving every 17 minutes. So basically we don't want to put too much NTP time traffic on the network.